I just scrapped an old Hewlett-Packard HP 4L printer, and this was one of the things that I took out. I know it's working, the printer was fully working. Unfortunately no Windows 10 drivers are available, so yeah, it's a bit of a shame, but I scrapped it. Seemed like no one else wanted the printer because it only had a parallel port interface as well. So anyway, a working stepper motor. I believe that it is a bipolar stepper motor. It's 4 wires. It should be really easy to get working on a driver, something like this. You'll see that these two coils represent the bipolar coils in a stepper motor. So we've got two pairs. We've got pair A and pair B, and so to use this motor, all I need to work out is what pairs the wires come in. Now there's a bit of a clue on most motors I've encountered anyway. They actually wire them as pairs, so I reckon the first two are going to be a pair and then the second two are going to be a pair. It doesn't matter which way around they are, just need to identify the pairs. So you can do this a couple of ways. The quick and easy way that I normally do, first of all, making sure none of the wires, I've stripped the wires by the way, they didn't come like this. I can turn that spindle and there is some resistance, but it's not, you can't feel any steps in it, it just feels reasonably smooth. Now if I then bring a pair together and just one pair and I try and turn it, now it's considerably, you'll have to take my word for this, it's considerably more difficult to turn, and then when I release it goes back to normal. So that's definitely a pair. And let's make sure they're not together, and now I've touched the other two wires together, and yeah, it makes it substantially more difficult to turn, and then when I release it goes back to normal. So just like I said at the start, red and white are a pair, blue and yellow are a pair, and it's a bipolar, so it's two pairs there. So that's really going to be quite easy to do. That's why I normally do it. The other way, you can use a multimeter. And so I've got it already, or I haven't, set it on to 200 ohms because I know it's going to be a low resistance. You'll notice the one, that doesn't mean 1 ohm, that means that the measured value, the resistance between these two, is greater than the range, so greater than 200, not surprising, there is going to be more than 200 ohms. So let's just put the two probes together. And so we do have the test leads themselves, or the meter, maybe it's not calibrated well, but we've got a measurable resistance there. And let's now go for one of these pairs, and yeah, I can measure a resistance in that pair of something just under 4 ohms. If I were to connect this probe clip to any of the other wires, I'd be expecting something that's out of range, because there should be no continuity between one pair and another. That's correct. So you would also expect each of the pairs to have a similar resistance. So let's measure that. And yeah, sure enough, about 4 ohms. So yeah, so each coil has a similar resistance. So they're definitely two pairs. So next thing that I'm going to do is the wires are too short really to be usable. They're also stranded wire that's quite fine, really easy to break. I don't want the wires to break off down there because that's really inconvenient, so I'm going to extend the wires. I'll probably also then put them in some braided sleeving like this. I'll heat shrink the connections as well so nothing shorts out. Probably cable tie it off to there. That looks like a good, nice, solid position there, so then there won't be any mechanical damage on those sort of joints because we don't want anything to break there. Yeah, so I'll do that in the next video, and then I will get it wired up to a micro step-in driver, and then we can test the motor just to see if it works. I'm fairly confident it's going to work. Okay.